Okay, go back to page 57 in your ISN and find where we made the circumcenter. And you should have this taped on page 57. And come down here on this space right here, and I just want to focus on the vocab because this unit is mostly vocabulary. If you do not know the vocabulary, you will not pass this test. So it's really important that all these words that I'm teaching you, that you need to go back and make sure you understand what they mean and what the pictures look like. So this is the circumcenter, and if you remember, the circumcenter is formed by the perpendicular bisectors. So here's what I want you to write. Perpendicular bisectors make a right angle and go through the midpoint. Perpendicular bisectors make a right angle and go through the midpoint. So I want you to draw a segment, and I want you to eyeball where the midpoint of that segment is, and you're going to show it's a midpoint by having tick marks. And then I want you to draw a segment that makes a right angle through that midpoint. And then grab a highlighter and highlight the tick marks and the right angle. If you have a triangle, and I'm just going to make this into a triangle so you guys can see. If you have a triangle that has tick marks and a right angle, then this segment right here is the perpendicular bisector. So you need to know perpendicular bisectors make a right angle and go through the midpoint, and the midpoint will be shown with tick marks. Okay? After you watch this video, you're going to get a sheet of paper that's got pictures like this. Cut the pictures out, and I want you to lift up your flap for circumcenter, and you're going to tape this picture, or glue, you can glue it, tape this picture underneath. So what you'll have is your handmade version of the circumcenter and then a computer-made version. Now, I want to talk about this picture before we go to center, or before we go to in-center. Do you remember right here where we said the circumcenter was equidistant from the vertices, and we drew in these orange segments and we said that these are all the same length? Well, look what we have here. Here is your circumcenter right there. That's where all the perpendicular bisectors meet. And do you see this circle that is going through each vertex of this triangle? That circumcenter is the center of this circle. And when I draw this segment from the circumcenter to here, that's a radius. And so is this, and so is this. So what you have in this picture is the radii, 1, 2, 3, the radii of the same circle are all the same. So I'm going to put a tick mark on these to show you that the radii are all the same length. The point of having this circle is to show that it's equidistant from the vertices, that this circumcenter is the same distance to that vertex as it is to each of the other vertices, because it's the center of this circle, and the radii of the same circle are all the same. So the point of the circle is to show you that the circumcenter is equidistant from vertices. So if you see a triangle with a circle on the outside, that is showing you the circumcenter, because the circle is showing it's equidistant from the vertices. Okay? All right, now pick up triangle, or go to page 58 where you have your in-center. And the in-center is made of angle bisectors. So right underneath your picture, I want you to write angle bisectors cut an angle in half. angle bisectors, cut an angle in half. And I want you to draw an angle and then draw an angle bisector that looks like it's cutting in half. You can just eyeball it. And if we're going to show that this angle's been cut in half, we're going to put an arc there and an arc there to show those two angles are congruent. So grab a highlighter and highlight here and here. When you have a triangle, and I'm going to make this into a triangle so y'all can see what the picture will look like. When you have a triangle where you've got an angle bisector, this is showing you that the point of concurrency is going to be the incenter, because you've got these two arcs here that are the incenter. Okay? Now find your pretty picture and hit pause if you need to cut it out. And you're going to tape this right underneath incenter. So we have incenter was made by angle bisectors, and we learned that the incenter is equidistant from the sides of the triangle. So see right here, you've got, we drew these segments, and these orange segments were all the same because the incenter was the same distance to each side. So when you look at this picture, do you see how we have a circle on the inside of the triangle now? The incenter is the center of that circle. And when I draw this radius right there, and this radius, and that radius, I drew them so, I kind of eyeballed it, but I drew them so these are all right angles. These segments are all congruent because they're radii of the same circle. So when you see a triangle with a circle on the inside, it's showing you that the incenter is the same distance to each side. So it's equidistant from sides. Equidistant from sides. So when you have an incenter, sometimes you'll see a circle on the inside of the triangle. That's showing you that the incenter is the same distance to each side of the triangle. Okay? Now, before we go on to the other two triangles, I want to show you a little trick. We have circumcenter and incenter. And the circumcenter is equidistant from vertices, and the incenter is equidistant from sides. Here's how I remember it, and you can remember it however you want to. Circumcenter is a longer word out of incenter. Circumcenter is a long word, incenter is a short word. When you're looking at vertices and sides, vertices is a long word, sides is a short word. So I remember that long words go together and short words go together. You can also remember that the incenter has a triangle, the incenter has a circle on the inside. Incenter has a circle on the inside, and since it's on the inside, it's showing that it's the same distance to each side. The circumcenter has a circle on the outside. This one's harder to draw. And the reason it's on the outside is it's showing the circumcenter is the same distance to each vertex. So this one's the incenter, that's the circumcenter. You can also remember that I and S make the word is. So you can remember incenter is equidistant from sides because it makes the word is. Whatever works for you, whatever thing you can use to remember, that's what you need. But you just need to know that vocabulary. Circumcenter is equidistant from vertices, incenter is equidistant from sides. Okay. Now turn to page 59, and we're going to look at our centroid. All right, so if you remember, we talked about a median, and a median connected the midpoint, because we had the tick marks here, to a vertex. So what I want you to write underneath this picture is medians connect a midpoint to a vertex. Okay, and then I want you to draw a picture of a triangle. And on this side, I want you to eyeball where the midpoint is. And remember, we show it's a midpoint by putting tick marks. And this is your vertex. And so draw a segment from your your midpoint to your vertex. And then grab a highlighter and highlight the tick marks and highlight the vertex. So when you see a picture where this segment is going from the vertex to a midpoint, that segment is a median. And then find your pretty picture for the centroid, and you can see it's got all the tick marks showing that it's the centroid. That's the only thing on this picture is the tick marks, because it's showing that it's connected to the vertex. So this is what your centroid looks like. Lift up your flap here and tape or glue that underneath. Okay. And then turn to page 60 and find your orthocenter card. And for the orthocenter, we did the altitude. And remember, the altitude is the height of the triangle. So underneath this, I want you to write altitudes show the height of a triangle. They connect a vertex with a right angle. So if I have a triangle here, this is my vertex. So if I'm going to draw an altitude, I'm going to drop a segment straight down that's going to hit this opposite side at a right angle. So draw a segment straight down and show the right angle. And then with your highlighter, I want you to highlight the right angle and the vertex. That's the key you need to remember to know it's an altitude. You have the right angle and the vertex, and there's no tick marks or anything like that. And find your pretty picture and see how this one, it just has the 3 right angles. Each segment is going through the vertex, but there's no tick marks. That's your clue that this is an orthocenter and not a circumcenter. If it was a circumcenter, it would have tick marks. Okay? So you're going to tape or glue that underneath your handmade card. All right? So what I want you to do now is go back to page 54. And you should have your poem that I told you to make. The example that I gave you on your table of contents was crunchy peanut butter is always better because Mom opened applesauce. So you should have, let me just show you on this one. You should have this poem written down on page 54. I want you to write the letters again. CPB, IAB, CMOA, write the letters again. And this time we're going to write down what they actually stand for. So the first one, the whole point of memorizing your poem is so you can remember these letters in order. So the first letter is for circumcenter. And circumcenter is formed by perpendicular bisectors. So that's your first part, CPB. Circumcenter is formed by perpendicular bisectors. The next letter is I for incenter. Incenter is formed by angle bisectors. The next letter is C for centroid. Centroid is formed by medians. And then O for orthocenter. And orthocenter is formed by altitudes. So your job is to come up with a poem that helps you remember these letters in order, and then to know what the letters actually stand for so you can learn all of this vocabulary. This unit is so heavy in vocabulary, and you really need to make sure you're studying that. Okay? In the next video, we're going to talk about where you can find the different points of concurrency based on what type of triangles it is.